Now that we've taken care of making sure that the number of electrons flowing to the left and the right are the same, it's time for us to balance those pesky oxygens which are sitting there. And we do that by recognizing that in acid, there's a certain set of rules, certain set of guidelines we need to follow. In acid, you're supposed to add 1 water to opposite the side for the number of deficient oxygens and put double the protons on the other side. That may seem kind of like out of there, but let's just go ahead and do it. This says, find the number of oxygens you're deficient. Evidently, I'm deficient 4 oxygens here, and add 4 waters to the opposite side. There, I've done it. 4 oxygens for my 4 oxygens. And then it says to put double the number of protons on the opposite side of that. That makes sense because I just put 8 hydrogens over here. I need to put 8 protons over here. And I'm balanced. That may seem like I'm coming from out of left field to have done this because there seems to be so much arbitrariness. The 5 electron flow, the 4 waters, the 8 protons. You would not in a million years by inspection think to do what I've just done. But I have just said that 8 protons and a permanganate and 5 iron plus 2s balances a manganese plus 2, 5 iron plus 3s, and 4 waters. Wow. We'll see if that's true. Let's balance the masses first. 8 protons, 8 hydrogens. Check. A manganese, a manganese. 4 oxygens, 4 oxygens. 5 irons, 5 irons. So my mass balance works. And now the drum roll, let's see whether my charge balance works. Here's 8 pluses, 1 negative, and 10 pluses. So altogether, this adds up to plus 17. Does this equal plus 17 over here? That's a plus 2 there, and a 5 times 3 is 15 there. What do you know? 17 on this side as well. Somehow, out of all of this, the plus 17 equals the plus 17. I have balanced this redox reaction. This may seem a little messy, but I actually got there very fast when I did it. Just to summarize, I wrote down the oxidation numbers. I found out that this was a 5-electron process and a 1-electron process. Lowest common multiple, I multiplied these values by 1, these values by 5. Then I saw I was short 4 oxygens, so I put 4 waters here, 8 protons there, done. Literally, took me about 15 seconds to do this problem. The amount of time to explain it, the amount of time to check it, that took some work, but look at how gratifying that is. 17 on either side for the plus charge, and therefore I've balanced this reaction, which is a pretty complicated redox reaction in water that's acidic.